One way I like to start a lesson is by engaging my students. And with this Reader's Theater on quadrilaterals, that is definitely one way to do it. If you're interested in hearing more of the Reader's Theater, you can find it on Teachers Pay Teachers by searching Quadrilateral Reader's Theater. What we're going to be focusing on today, though, is the following standard in 5th grade. It is 5GB3. Understand that attributes belonging to a category of two-dimensional figures also belong to all subcategories of that category. For example, all rectangles have 4 right angles and squares are rectangles, so all squares have 4 right angles. We're also going to be going into 5GB4. Classify two-dimensional figures in a hierarchy based on these properties. The tasks I'm going to do build on the lessons from 3rd grade, when students described, analyzed, and compared properties of two-dimensional shapes. They compared and classified shapes by their sides and angles, and connected these with definitions of shapes. In grade 4, students built and drew and analyzed two-dimensional shapes to deepen their understanding of the properties. They looked at the presence or absence of parallel and perpendicular lines, or the presence or absence of angles of a specific size to classify two-dimensional shapes. But now, students are going to classify the two-dimensional shapes into a hierarchy based on properties. We're also calling these the attributes of shapes. Details learned in earlier grades need to be used in descriptions of the attributes of shapes. The more ways that students can classify and discriminate shapes, the better they can understand them. And when they head into 6th grade, they're going to be solving real-world and mathematical problems involving the area, surface area, and volume of shapes. The best way to get students started is to go back and explore some of the shapes and quadrilaterals that you may have done in a previous lesson. Using the ang legs, you can form all sorts of different types of quadrilaterals. They can be manipulated, as you can see, to help students understand the relationship between each of the quadrilaterals and their shared attributes. A common activity involving geometry is for students to recognize and name various polygons. Their experiences with 4-sided polygons may lack depth and may have some misconceptions. For example, students are often taught to categorize rectangles and squares separately. Typically, a polygon with 4 equal sides and 4 equal angles is referred to as a square, whereas a polygon with 4 equal angles but 1 pair of long sides and 1 pair of short sides is referred to as a rectangle. We hear students refer to rectangles as being long or tall. Their system for differentiating between squares and rectangles is based on narrow experiences with only a few specific examples. These constructions may cause confusion later on as students learn that squares also fit into the description of a rectangle. This new information does not fit logically to what they have already learned, and it does not allow for growth and understanding that a square is a more specific classification of a rectangle, just as a rectangle is a more specific classification of a parallelogram, and that a parallelogram is a specific classification of a quadrilateral. These shapes all fit into the quadrilateral family. If students are having trouble identifying the different quadrilaterals, before you place them in the hierarchy, you may want to revisit some of these quadrilaterals and make some comparisons. Prior to this lesson, you may have completed an attribute chart such as this one below. You can ask the students to choose some of the shapes and compare them using a Venn diagram. You can also have students work along with the ang legs again, or a geoboard and geodot paper to make some comparisons as well. We want to look at what all the shapes have in common. How are they different? How they fit into multiple categories. We want to classify and understand the relationships based on these attributes. Let's do that now. We're going to compare a rectangle and a rhombus. We're also going to contrast, so we'll look at the differences as well as the similarities. If we label the left side rhombus, and the right side rectangle, just switch my shapes around. Students can work by using their manipulatives to see if they can remember the attributes of these shapes, and they can actually work with one of the shapes at a time. Or they can just revisit the attribute chart that they did the prior day. When we're looking at the attribute chart, we see in the first column that a rectangle and a rhombus both have two pairs of parallel sides. So we're going to put that in the middle. We can also see that both shapes, right here, have four sides and four angles. One thing that your students also can note from that was not found actually on our attributes chart, is that the opposite sides of each figure are congruent. You also will notice that both shapes fit into the category of polygon. Both are also quadrilaterals. I'm just going to abbreviate and put quads. And they also are both parallelograms. And you can see here one pair of parallel sides, two pairs of parallel sides, opposite angles are equal, opposite sides here are equal. But one thing that makes a rhombus different is that a rhombus must have four congruent sides. And one thing that makes a rectangle different is that it must have four right angles. Something that they may not see at first, but can see, write down the parallelograms, by looking at their chart, is that a square has all of the attributes of the quadrilateral, which means that a rhombus and a rectangle are both also classified as squares. After doing this, students will be able to get a better understanding of the differences between different shapes in particular. And they'll also be able to then see some relationships to help them in forming the hierarchy that we're trying to achieve by the end of this lesson. Now, one misconception that you'll also see is that when students are placing these shapes into categories and into subcategories, they think that the last category they place them in might be the only classification that can be used. And therefore, they're unable to sort the shapes on a hierarchical chart. We're going to demonstrate how we can help the students to form a flow chart, almost like a family tree of quadrilaterals. Again, your attribute chart from the prior day will come into play because you're wanting to note all of the relationships between each of the shapes. You should make sure that the students understand what type of diagram you're trying to make and discuss that you're looking for shapes to be classified into categories and subcategories. We know that the title of the entire family, the overarching shapes that we're looking at here, is the polygon called a quadrilateral. Now, I'm looking here at the main types of quadrilaterals that we have, which are rectangle, rhombus, square, kite, parallelogram, and trapezoid. When I look at my attributes chart of quadrilaterals here, I'm seeing that a trapezoid only has one attribute that is shared with the other quadrilaterals, and therefore cannot really be classified under any of these quadrilaterals. So it's going to be off by itself. I'm going to save that one for a little later. Now I also see that a kite here only has one attribute, but it doesn't share the attribute of a trapezoid. So that tells me it's also not going to be related to a trapezoid or any of these other specific quadrilaterals. But these four quadrilaterals here have different relationships. The first relationship that we can note is that quadrilaterals all have four sides, which, again, all of these shapes have four sides. We also can note that certain quadrilaterals have to have sides that are parallel. So I know that my quadrilateral that I'm going to look at first at the top is a parallelogram. A parallelogram has to have two pairs of parallel sides. So does a rhombus, so does a square, so does a rectangle. So I'm going to place my parallelogram right here. Now, I can also note here that my parallelogram, which has the two pairs of parallel sides, opposite angles are equal, and opposite sides are equal, may be related to these three other shapes. Now, I see here that a rectangle and a rhombus both have the two pairs of parallel sides. They both have opposite angles that are equal, same as a parallelogram. And they both have opposite sides that are equal, just like a parallelogram. So I think that they can be classified as parallelograms. So I'm going to draw a connecting arrow to those two shapes. Now, it says here that opposite sides are equal and there are four right angles in a rectangle. Now, all the sides are equal in a rhombus, but a rhombus, as you can see, does not have 4 right angles. It has 2 acute angles on this particular rhombus and 2 obtuse angles. Students would have learned that when they studied and compared and classified triangles. So I'm looking now at the square, and I know that the square also has 2 pairs of parallel sides. Opposite angles are equal. Opposite sides are equal. It has 4 right angles, and all sides are equal. So that tells me that a rectangle and a rhombus are both related to a square, because a square can be the rectangle and it can be a rhombus. But a rhombus and a rectangle cannot be a square because it has to have 4 right angles to be a rhombus. To be a square. A rhombus would have to have 4 right angles to be a square, and a rectangle would have to have 4 sides that are of equal length, which we don't have. Now we can see, though, that it still falls under the family of quadrilaterals, parallelogram. So that square is related to those shapes. Now we can put in our other quadrilaterals. We have our trapezoid and our kite. Neither one of these can be related to a parallelogram because the parallelogram has to have parallel sides and 2 pairs, and a trapezoid only has 1, and a kite doesn't necessarily have to have any.